Hello and welcome to the second chapter of CCSW. In the first chapter, we looked at preference relations, we proved certain results, we looked at maximal sets, choice sets, and finally, we also saw when a choice function could be defined, when we define choice functions using binary relations, when it would be well defined, what sort of conditions do we want on our binary relation. In this chapter, having proved all of those results for basic preference relations or binary relations, we are going to move into collective choice rules. So before we begin this chapter, some terminology is in order, right? First of all, what is RI? Right? RI is the ordering of social states of individual I. Right? And there are n such individuals. Okay? So R1 is the preference of the first person over different social states, which brings me to the next bit of terminology, which is X, which is the set of social states. I already described to you what a social state looks like before. Right? S is any subset of X. We have already dealt with such S's before. And finally, R is the social choice relation. Okay, keep this in mind very clearly. Right? Now, as we have told you, social choice theory is about going from Ri to R. Right? So when you go from Ri, all the NRIs to R, right? You go using a collective choice rule. This is what a collective choice rule is. A collective choice rule is a functional relationship between the RIs and R. Right? So for any given RIs, if I know the ordering of each individual, if I can give you the social ordering, that is a collective choice rule. Right? Now, one condition which exists already. Condition on RI. What is it? They are orderings. So all the RIs have to be complete, transitive, and reflexive. Right? Why? It's a very simple reason. Social choice theory doesn't really deal with how individuals actually form their preferences, right? Social choice theory is about how from these preferences we can go to a social preference, which has certain desirable qualities, and we investigate that. So for that social choice or social preference to have certain desirable qualities, individuals first of all must have proper preferences in the first place, right? That is why we make this assumption. So they have to be their orderings complete, reflexive, and transitive. All right, because otherwise social choice theory would be going from irrational individuals and going to a social choice. And then if we prove that rational social choice is impossible, it's not a very interesting result, because the components of that social choice, these individuals, don't have rational preferences in the first place, right? So having got that out of the way, I think we should move on, right? Now, note that we imposed a condition on our rights. We didn't impose any condition on R yet. Of course, we want certain desirable properties of R. One way in which we could define R is some constant, right? One way to define. Why would this be bad? So R is equal to constant irrespective of what the RIs are. My R is fixed. So social choices does not depend on individuals, right? This is also a collective choice rule, but it's obviously intuitively doesn't feel good, right? Because you're not taking into consideration individual preferences. So naturally, from this flows a basic fact. We want certain conditions on R. We want R to fulfill some conditions. If R could be an ordering, that would be great, right? If R was an ordering, that by all means mean that R is fairly rational, right? Along with some other conditions we will impose later on. The first condition we impose on R, right, is decisiveness. What does it mean? Decisiveness or completeness, right? You want R to be complete for all given Ri's, right? So if I have given you Ri's and I give you some X and Y, you should be able to tell me whether X are Y or Y are X or both, right? So from this comes a definition. A collective choice rule R is decisive that gives R, right, is decisive if R is complete. Mind you, the RIs are preference relations. R is also a preference relation. RIs are complete, transitive, and reflexive. Right? But we can't impose conditions on R because we are defining how R comes from. We are defining the collective choice rule. So this is one condition on R which we would like for it to fulfill, right? And we will soon investigate when it fulfills these things, right? For now, just keep this definition in your mind while we define some other things. So let me define for you of the Pareto relation, right? R, right, is a relation on X. So R bar is a relation on X, right? Using a collective choice rule. Right? How is R defined? X R bar Y if and only if X R I Y for all I. So if every individual thinks X is as good as Y, then and only then is X R bar Y true. Right? This is a definition of a collective choice rule. Right? This is how we define it. This is a very basic collective choice rule, the Pareto collective choice rule. As you can already imagine, this is a very strict one because we are saying if and only if. More on that later. X P bar Y, right? P bar is the asymmetric component of R bar. If and only if X R bar Y and not Y R bar X. Right? And similarly for Y R, I bar. Okay. So this is the R bar binary relation, right? And the R and the collective choice rule associated with it. Now let's look at certain results. But before that, a few things which are important as we move forward. What does this symbol mean? Right? It means that R is same as R bar, right? So R bar, so X R Y, if and only if X R Y. Versus this. What is the difference? Right? Let me explain to you. This is a definition of R, right? This is a condition on R. Here you're telling me what R is and what R is not. When XRY is true and when XRY is not true. Right? Here you're only telling me when it should be true. So if X R bar Y is true, that is, if everybody thinks X is at least as good as Y, then X R Y should be true. But this is not the only way X R Y can be true. It can be true for other cases also, even when X R bar Y is not true, right? So this is a condition on R. If this is true, R should follow. Here, it's the definition of R because this is the only situation where R can be true. All right. This difference is very important as we move forward. The difference between a definition and a condition. Anyway, let's look at R bar. Let's investigate R bar. Right? Is it a good collective choice? Is it good? As a collective choice rule, as it turns out, it's not very good. Why is that true? Well, it's not decisive, right? And this should be, I think, intuitively clear. Because R bar is a very strict reference relation. So if everybody thinks X is at least as good as Y, then X R bar Y is true, and only then is X R bar Y true. But what about a case where, say, out of n people, or out of 10 people, 9 people think X is at least as good as Y, but the 10th doesn't, right? Then X R bar Y is not true. What happens in those situations? R bar tells us nothing. So R bar is actually incomplete. And here we will actually go ahead and prove a lemma. Not, so the answer is not as a collective choice rule. It may be good as a condition you want to impose on a collective choice. So lemma, R bar is a quasi-quantity, which means it is reflexive and transitive. So it's a good condition, but it's not complete, and hence it's not decisive. Very easy. This is a very basic proof. I'm doing this because I think this is the first time we are dealing with RIs and we have a collective choice rule. So let me prove it. Reflexivity. Right? Why is this true? Since RI is an ordinary. Okay. So this implies, so reflexivity is true. Transitivity. Right? Suppose XR bar Y, YR bar, sorry, YR bar X, sorry, YR bar Z implies XRI Y, YRI Z for all I. Implies XRI Z for all I, right? Because RI is an ordering and so it's transitive. Done. Right? So we have proved that it is reflexive and transitive. Now to prove that it is a quasi-ordering, we also prove that it is incomplete. Let's see. Incomplete. How do you show this? For this, you have to construct a counter example, right? So suppose not XR1Y and not YR2X. Ask yourself why I used 2 here and 1 here. Why I didn't use 1 again here, right? That can be your exercise. Hint, this is a hint. Anyway, suppose this is true, then not XR bar Y, right? Because for I equal to 1, XRI Y is not true, and not Y. And hence we have proved incompleteness and we have proved that it is a quasi. But can we salvage the situation? But can we salvage R bar? Yes. If we impose certain conditions on the individual preferences, then R bar can be complete, right? What is that? R bar is decisive, right? If and only if there exists I such that XPIY implies XRJY for all J. Okay? If this is true for the individual preferences, this is a condition on individual preferences. Individual preferences. Right? Now, necessary. Why is this necessary? use last counter example, right? And check that it does not satisfy this condition, and hence it is necessary, right? So we can give you a counter example when this is not true. So R bar can't be decisive if this is not sufficiency. Sufficiency. This is very easy to do, all right? I will use a slightly different method compared to the book. I think it's slightly shorter. So suppose not x bar y, right, implies that there exists I such that not xri y, this is very clear, implies y pix. Y, exercise for you, right? Implies y rjx for all j, implies y r bar x. Done. Right? We have proved that R bar is complete in this situation. If and only if this condition is true on the individual preferences. But of course, this is not very nice. We don't want to have any conditions on individual preferences other than them being rational. Because then, you know, that's a way of cheating in social choice theory. You cannot expect individuals to cater their preferences because you cannot find a good collective choice rule, right? So this is just an aside, an interesting relation found not very useful in practice. Now, after this, the book gives you certain definitions about a weaker version of the strict Pareto relation, which is not very relevant for us. We will move on to the next bit now. We discussed this partially before. If this is true, right, we say R is Pareto inclusive. It's if this condition is true. Okay, right? This and this actually. If these two conditions are true, again, these are conditions and not definitions of R, then we say R is Pareto inclusive, right? This is one definition. Another definition, right, before we draw our discussion of Pareto to a close, is that of Pareto optimal states. Pareto optimal social state. What is a Pareto optimal social state? Let's understand. X belongs to X is Pareto optimum if and only if, right, there does not exist. So there exists Y such that Y p bar X. If this is not true, then X is called Pareto efficient or Pareto optimal social state. This is very simple. If X is a social state such that no social state is strictly preferred to it using the Pareto method, then X is said to be Pareto optimal, right? Now, an aside on this, why this is a problematic way, why this is problematic, right? This essentially means that if in a social state X, say one person has everything, right, while others have nothing, right, it is still Pareto optimal. Why is this true? This is because if there's any other social state Y, this one person will not like it, right? So for any Y, because for all Y, YRIX is not true. Sorry, YR1X is not true for this one person, right? Which implies that YP bar X is also not true, right? So, nothing about equity in this definition. So, social state may be Pareto optimal, but it still might be really, really disgusting, is the word the book uses. We will now prove a very interesting lemma, right? What does it say? For finite x, there exists at least one Pareto optimal social state, right? For all individual objects, right? Now, the book proves this very directly, and I do prefer that proof. I think it's a very neat proof, and you can refer to our older videos for this. So, we have shown R bar is a quasi-ordinary. The argument of this proof is stunningly simple and elegant, right? Now, the maximum set is the same as the Pareto optimal set. Okay, very, very interesting argument, very elegant argument. Why? Check the definition. Check definition. Right? But we know from chapter 1 that for finite x and for finite s and quasi ordering R, M of s comma R is not empty. Done. 3 lines, right? To prove a very profound result. Every finite set X, there is at least one Pareto optimal social state for all individual orders. And we proved it through this really, really elegant argument without actually going into the proof directly, which we might have done, and you might try that as an exercise. We will now go into the concept of compensation tests. This is yet another way of defining a collective choice rule. Right? Another way, another type of collective choice rule. What is the idea? Right? The idea is just simple. Right? Suppose there are x and y, x comma y, which belong to x, the set of social states. Now, from x, you can redistribute, maybe using taxes, subsidies, etc., to various other social states, right? So let's call this set Sx. Right? What is it? The set of social states we can go to from x, right? Using redistribution. Right? Now, if there exists z belongs to S of x, right, such that z p y, then x p y. This should be intuitively very clear. Right? If there are two social states x and y, you can go to z from x using some redistributive measure such that z is better than y, then x should also be called better than y, because we can easily just go from x to z and since z is better than y. Okay. And the question, of course, is what is this p, right? Because I have not defined p as from any collective choice in the end. So of course, you need to define some P on the basis of which you do this compensation test. And here comes the notion of, or here comes the idea of the Caldor compensation test. Right? Caldor test says in this above definition, P is equal to R. Right? So if there exists Z belongs to S of X such that Z P bar Y, then X P Y. That is how you define the collective choice, right? So note, P bar is not the collective choice. Right? P bar is being used to define this new collective choice rule, right? Which is called the Caldor compensation test, right? But there's a problem with the Caldor compensation rule, right? Which is this. Lemma. No collective choice rule can satisfy consistently the Caldor test. Why? First of all, consistency here means that, you know, if X is better than Y, Y can't be better than X. That is what consistency is. This is simple. There exists Z such belongs to S of X such that Z P bar Y, and there exists W belongs to S of Y such that W P bar X. Then X P Y and Y P X, and nothing precludes Z and W from existing, right? So therefore, Caldor test gives us an inconsistency, which is of course a sad result. But there is a way to mend this as well, the same way in which we mended the Pareto principle, which is Skitovsky test, right? Skitovsky's test says XPY if and only if XPY according to the Caldor test and YPKX is not true according to the Caldor test, right? This is the Skitovsky test, right? So of course, naturally, we take away the inconsistency because here it's not possible to have an inconsistency because we are defining it in this way, right? And then the book notes two lemmas which I'm not going to prove because they're not that important, right? Here, P may be intransitive is the first lemma. May be intransitive. And the second lemma is condition for P intransitive and asymmetric, right? And you can check these out from the book, right? So this essentially tells you that under the Skitovsky test, you might have an intransitive, right? Or an intransitive P may satisfy the Skitovsky test. This is the first lemma, a very basic proof using a counter example. The second proof is more involved, but it's not very, it's not something we get very much out of. So we will not prove it here. So we will put a condition on this Skitovsky test and on the redistribution sets to show that if that condition is fulfilled, P will be transitive and asymmetric only then. Right? The same thing which we did with Pareto optimality. So the lesson from the second chapter is something different. Right? The lesson from the second chapter is this. Right? First, we saw the Pareto relation. Then we saw the compensation tests. So these are certain rudimentary conditions that you want. These are rudimentary conditions that you want your rudimentary conditions that you want your collective choice rule to satisfy, right? But in and of itself, right, they are not enough to define a good collective choice rule. In the case of Pareto, we saw how it usually exhibits completeness unless we specify what sort of individual objects we have. And under these compensation tests, first we saw that Caldor can give you an inconsistent compensation test. And even if we use Titowski's principle and renew the test, even then we get an intransitive preference relation that satisfies the test. So these are certain rudimentary conditions which can be imposed on a collective choice rule, as we will see later on. Right? In fact, the Pareto relation is a slightly weaker Pareto relation is a part of Arrow's famous theorem. It's a condition of Arrow's famous theorem. But we still have to develop our theory further, right? We need to see how many conditions we can go on and give without, until we put collective choice theory to the breaking point where it can no longer yield a collective choice rule, which is what happens in Arrow's case. At the same time, we also need to keep looking for collective choice rules, which may be better, which satisfy these conditions but are not limited, right? And we will do that in the next chapter. Thank you very much. Hope to see you in the next video.